So let's work through this example here of finding the area between two curves. So we have the function f of x equals 6 minus x squared, and we have g of x equals x plus 3. Now you could put these functions into the graphical calculator and see exactly what they look like and see the area that we're trying to work out, or you could do just a simple little drawing just down below. So we'll do something like that here. So we're going to have some function here. Now it's minus x squared, so we know it's going to sit like this. So we're going to have a minus x squared function. Now I don't know where it's going to sit, but it's just rough. We're going to be something like this. And then we're going to have this function here, g of x equals x plus 3. So that's g of x equals x, and plus 3 cuts through some point up here. So we're going to have a line that kind of comes like this. And we're going to have a crossover here, and we're going to have some crossover here. And we're going to be looking for the area between these two curves. But in order to do that, we're going to have to find where the crossover points are. So let's do that next. So I'll rub this out, and as I said, you can always go and have a look and create this in the graphical calculator for yourself. So we're going to get the crossover whenever f of x is equal to g of x. Well, f of x is equal to this here, and g of x is equal to this here. So we'll get f of x will equal g of x whenever this here is equal to this here. So we're going to have 6 minus x squared is going to equal x plus 3. So I could take the x squared across to the other side, so that would become plus x squared. I could take the minus x across and become plus x, so that would be plus 2x, and I would take the 6 across and it would be 3 minus the 6 would be minus 3, and that would equal 0. So now we have to solve this for x. So this is a quadratic equation. Now we're going to cover quadratic equations later on in the course, but I'll show you the solution to this one here. So in order to solve it, we can put it into two brackets equals 0. So we're going to have a value of x and a value of x, and in order to get 3 we have to multiply 1 by 3. So we're going to have x times x will give you x squared. We're going to have plus 3x, so that would have to be a plus 3x, and this one here would have to be a minus, so it would be minus x, and then this minus times the 3 would give us a 3. So we can check that out. We're going to have x squared, we're going to have 3x minus x, which is 2x, and we're going to have minus 3. So the roots then are going to be x equals 1 and x equals minus 3. So these are the 2 points where it will cross both the functions f of x and g of x will cross each other, so they're the x coordinates. So these x coordinates in effect are the limits of our integration. So we can write down the integral then as the integral from 1 to a value from minus 3 to a value of 1. Now we've seen here as well that we can, from the graphical way that it was drawn, we're going to have a function which again looks something like minus x squared is like this, and the line is like that. So it's going to be this function f of x minus the function g of x will give us the area in between. So the f of x is going to be the 6 minus x squared. So it's going to be this one minus the x plus 3. And we're going to differentiate that all with respect to dx. So I'll rewrite it here. So we're going to have the integral from minus 3 to 1. So we're going to have minus x squared. Okay, and we're going to have the minus x, so it's going to be minus 2x, and we're going to have the 6 minus the 3, which is just the value of plus 3. So we're integrating that with respect to dx. So I'll take this and I'll put it on the next page and we'll do the integration and we'll find the area. So let's do this integration here now. That's going to equal x squared, so we have to add 1 on, so that's going to be minus 1 upon 3 x cubed, and this is going to be minus, now it's the power of 2 divided by 2, so it's minus x squared, and this is going to be plus 3x. So we've got to integrate that from the limits, so we've got to put in the limits minus 3 to 1. So let's put the values in. So we're going to have our minus 1 upon 3, for when we put the 1 in, we're going to have minus 1 and a value of plus 3. Now the second part is going to be minus, and we've got to put the minus 3 in. So this is going to give us 27, but it's minus 27. And then this is a minus, so it's going to give us plus 27 upon 3. So plus 27 upon 3 is going to be plus 9. And we're going to have minus 3 squared, which is 9, but then it's a minus sign, so it's going to be minus 9. And then we're going to have 3 times minus 3, which is minus 9. So that's going to give us a value of, well, it'll be minus 1 plus 3, which is 2 minus a third. So it's 2 minus a third. And the second term here is going to be plus 9 minus 9 cancel. So it's just minus 9, but it's minus minus 9, which is plus 9. Okay, so it's just going to be minus minus 9. So finally, this is going to give us the value of plus 9 plus 2 is plus 11. That's plus 11 minus a third, which will equal 10 and 2/3. So that there should be the area under the curve, the two curves. But what we can do is we can put it into the graphical calculator and see whether this is actually the right value. So that's 10 and 2/3. But we can also write that as 30, 10 is 32 upon 3. So let's put it in the graphical calculator and see if we get this as the correct answer. So I've written in the two functions. We've got f of x equals 6 minus x squared, g of x equals x plus 3. So you can see the f of x in red, you can see the g of x in blue, and you can see the point where both of them cross over. So the x coordinate of the crossover is minus 3, and the other x coordinate of the crossover is a value of 1. So the limits are minus 3 to 1. So let's look at finding the area. So we can do this in the graphical calculator. So we can type in int, so int for integral, int, and you'll see the integral sign appearing. And you can put the limits in. So the limits are minus 3 and a value of 1. And we're going to have the function, we said f of x minus the g of x. Now we're going to have to put a bracket around all of it, and that's all by dx. And you can see it's given us the answer here, which is 10.666, which is going to equal the value 32 divided by 3. So it does work. Now, an interesting question is, what if you had mixed these up? What if you had accidentally done g of x minus f of x? What answer are you going to end up with? So let's have a look and see. Let's say we had written this in as g of x minus f of x. You'll see that the answer is minus 10.666. So obviously you're not going to get a minus area. So the actual answer is 10.666, and it just tells us that you've got these round the wrong way. So there's not actually necessarily a wrong way of doing it. As long as you get the answer, and you know when you get a minus answer, the actual answer is positive. So thank you for listening. I'll get you on the next video. Goodbye.